Hi there. Today I'm going to build a power supply to run a 100 watt LED. This big mother here. I'm going to use a conventional transformer with a regulator, and first step is to just see how to go about designing it. So let's look at that piece of paper. Alright, I'm going to start with the schematic of the regulator. I'm going to use a 317 HV high voltage. We have in, adjust, and output. Now, the way these things work is they keep 1.25 volts between these two pins. And if they don't have that voltage, there's a little guy in here turns the current up. In other words, the resistance between in and out goes down. So you have to put a resistor. So you've got 1.25 volts across the resistor. Always use a 220. Now, to adjust this, you need a resistance to ground. How does this work? Well, you have a voltage here. You're going to have a voltage here because of the current. We know the current because we know the resistor and we know this voltage. The current is about 5.7 milliamps through that. So if I wanted, say, 30 volts or so up here, I know I'm going to get 28.75 volts here. So 28.75 volts, 5.7 mA. I've got up on my chart. I need a 50-60 ohm resistor. Now I'll make that adjustable. Put in, I guess, a 10K adjustable so we can adjust what we want. And this is, of course, the input. This goes to our LED. Now, if we want 100 watts here, we're going to need about 3 amperes or more. This guy's going to develop maybe 32 volts, something like that. So this chip can't supply 3 amperes. It can only supply 1.5 at the most. So we need to boost that up. Now that's not difficult. Put in a pass transistor up here. Now remember, this changes its resistance if this voltage is wrong. In other words, if that voltage is too low, this would try to be too low, so it would decrease its resistance to increase the voltage, right? So that's a variable resistor. If we connect that transistor in here, we're going to need a resistor here because we can't short the base emitter. Transistors work by, they turn on when you bring the base potential towards the collector's potential. You turn the transistor off by bringing the base potential to the emitter potential. So this guy's going to automatically turn up the current through here. We're going to find about 25 times more current through this transistor now than through the chip, because of the beta of a power transistor. I selected a 2N. What did I pick? A 2N 5875. That's a 10 ampere, 150 watt. Where's the camera? There it is. It's one of these guys. I have a whole box I got surplus, so I use them. Okay. So now we've got our voltage, we've got our boosted current, everything's running good. One little problem, LEDs tend to heat up and take more current. Because this is a fixed voltage, that current could go up too high, depending on how hot that guy gets. So we need current limiting. How do you get current limiting? Well, first of all, you need a resistor here. to measure the current, you're going to develop a voltage whenever there's a current through here. That voltage we're going to send to another transistor. This time it's NPN, that's a PNP. That, look at a resistor here, connect it to our adjust. Now what's going to happen, as the current goes up, the voltage goes up, turns this transistor on, turns down our adjust, turns our voltage down. These transistors start to turn on at around 0.6 volts. Start to turn this guy on. We can put a resistor in, well actually in here, and we can, never mind that, we can adjust our set point for current. And that's our power supply. Not counting, of course, we're going to have a transformer and a bridge rectifier, right? And a capacitor to give us our plus and minus. I might do a video more on this, plus how to adjust the voltage of our transformer. We can't buy the exact right transformer to get efficiency. I'll show you how you can play around with that. So let's take a look at the circuit. I breadboarded the circuit here. Power this guy up. And I've got one LED on. And can you see the two LEDs? I guess you can. Here's one, and it's off. Alright. My current limiter transistors here. I've disconnected it to show you what's going on. I can adjust the voltage here and adjust the brightness of the LED. You see the current changing. Now the idea would be to set your current voltage to what you want. Enable your current limit, which is at 0.4 at the moment. I don't have an adjustable resistor. Now if I add more current, I'll just add another LED in here. You see the current go way up. That's because the voltage is stabilized by the chip over here. So I doubled the current. If that happened to your normal LED, you might burn your LED out, right? So let's enable our current limiting. Now if I try to add another, see the current stays the same. Voltage drops. That's what would happen if your LED were to heat up, try to take more current. It can't. The current limit turns the voltage down. Actually works pretty good. It's not perfect, but it's better than nothing. Especially since I didn't spec that transistor. I don't even know what it is. I found it in my junk. Anyway. That's it for that. See you later.